Okay, so let's continue. Let's continue with our discussion on expressing concentrations. So in the last video, we discussed on how to express concentrations via percent concentrations. Now we will continue with molarity, molality, and normality. So let's have molarity first. Now before we discuss molarity, let's first review. Okay, let's first review these two terms. We have here mole and then the atomic or molecular weight. So when we define mole, it is the SI unit for the amount of a substance. So 1 mole is equivalent, diba, to 6.02 times 10 raised to 23 pieces. And when we say pieces here, we refer to atoms, molecules, or particles. And remember, when we say 6.02 times 10 raised to 23, we're referring here to the Avogadro's number. Okay? For the atomic weight naman po, this is the same as saying atomic mass. So you can see it beside the chemical symbol in the periodic table of an element. Or rather, beside the chemical symbol of an element in the periodic table. Okay? Then for the molecular weight po, is defined as the actual mass of the chemical particle relative to the mass of the carbon atom. Another definition for your molecular weight, and this is actually the definition that we're going to apply in solving molarity, molality, and normality, is that your molecular weight is the sum of all atomic masses in a molecule. So now, before I proceed in the next slide, I would also like you to review on how we solve for molecular weight and moles, because those are very important in the discussion for this topic. So let's have an example. So for example, I want you to calculate for the molecular weight of water. So to do that, you need first to determine the atomic mass of oxygen and hydrogen, correct? So for oxygen, that is, if you're going to refer to your periodic table, that is 16. For hydrogen, it is 1. But remember, water has 2 hydrogen atoms. So that 1 there should be multiplied to 2. So 16 from oxygen plus 2, and you'll get 18. And remember, what is the unit for molecular weight? That is grams per mole. No? So when we say what is the molecular weight of water, your answer should be 18 grams per mole. Now, let us try to solve a mole. No? Like for example, how many moles will a 5 gram or will 5 grams of water have? No? So to determine the number of moles, the formula will be the mass of substance divided by the molecular weight. Okay? So the mass of the substance is 5 grams. You divide that one to the molecular weight, which is 18. So 5 divided by 18, and you'll get 0.28 moles. Or you can write moles as its abbreviation, no, as like MOL. No? I will accept either. Okay, so that's for the review on calculating moles and molecular weight. Now let's proceed to the molarity. So molarity is the number of moles of solute in 1 liter of solution. There are actually 2 formulas for molarity. But anong formula or anong form ng formula ang ginagamit ko? The second one. Okay? Mas ginagamit ko to siya. So molarity is equal to the weight of the solute divided by the molecular weight times the liter of solution. And there are 3 possible units for molarity. You can have moles per liter, or yung capital M na read as molars, or yung abbreviation ng moles per liter, which is this, MOL per liter. Okay, so let's now have examples. So for the first problem we have here, there are 20 grams sodium chloride in 400 ml of solution. So what is its molarity? So again, we will give the atomic weight. So kayo na po ang bahala mag-solve for molecular weight. So you have only one formula for molarity. So this is the formula, right? So molarity is equal to the weight of solute divided by the molecular weight times liter of solution. So you just plug in the values. So 20 grams divided by, what is the molecular weight of sodium chloride? That's 58 grams per mole. Okay. Times 0.4 liters. Bakit 0.4 liters? Bakit hindi 400? Kasi remember, di ba, sa formula, it should be liters of solution. So the given is 400 ml, so you need to convert that one to liters. Kaya po, Ang result, 0.4 liters ang nakasulat dito. Then you solve and you'll get 0.86 molars. Okay, and don't forget to box your final answer. Okay, so let's proceed to the next problem. So how many grams of sodium hydroxide are contained in 500 milliliters of a 4 molar solution? So again, given po yung atomic weights ng ating elements comprising sodium hydroxide. So we use again this formula, and then what is required from the problem is the grams, or rather the weight of the solute. So substitute the values, no, from the given problem. So you have here, given yung molarity, but in this case, no, I converted for molars to moles per liter. Hindi naman converted, but rather I used, no, the synonymous unit of molar, and that is moles per liter. I did this for you to see, no, bakit ma-cancel yung mole at saka yung liter na unit, and ang matira na lang ay grams. Okay? So you have here 4 moles per liter equals the weight of solute divided by the molecular weight of sodium hydroxide. So NaOH mo na si sodium hydroxide, so you're just going to add this. So 23 plus 16 plus 1, and you'll get 40 grams per mole times, since the given is in milliliters, so you need to convert this one to liters. So 500 milliliters converted to liters is 0.5 liters. And then you're just going to multiply the 3 numbers here. So 0.5 times 40 times 4, and you'll get 80 grams. So 80 grams now is the final answer for this problem. So for the next problem, it's actually similar to this, no? So if sodium chloride has a gram molecular weight of 58 grams per mole, how many of the solute is added to 6 molar solution of NSS to come up with 2 liters? So if you're going to plug in the values, so you have here the gram molecular weight. So this is 58 grams per mole. And then given na po yung liters, so you do not need to convert it, no? So that's 2 liters. You're just going to place it here. And then given na rin po yung molarity, which is 6 molars. So you're going to place it here. Okay? So then you're going to multiply the 3 numbers. So this 2 liters times 58 times 6, and you'll get 696 grams. No? And that is the final answer. So you're going to box that one. Next problem. A solution contains 3.5, that contains, you know, yung subject-verb agreement. A solution contains 3.5 grams of hydrochloric acid in 1 liter. How many millimoles does it contain? And then given again yung atomic weights ng H at saka ng hydrogen at saka ng chlorine. So given in the problem, or given, no, or based rather from the problem, and from the question of the problem, it is very important that you know, no, na hindi po involved dito yung formula for molarity. Bakit po? Kasi ang tinatanong dito ay millimoles. So magfo-focus lang tayo doon sa formula ng ating moles, correct? And what is the formula for moles? No? To get mole, we have weight of substance divided by the molecular weight. So from the problem, the weight of the substance is 3.5 grams divided by the molecular weight. So what is the molecular weight of hydrochloric acid? But that is HCl. So you're just going to add these two. So you have 35 plus 1, and you'll have 36. So divided 2. And again, don't forget the units and the cancellation of units. No? Mas maganda po, no, pag medyo beginner pa or medyo nakalimutan na, no, medyo hindi ganun kagaling, no? I-cross talaga natin yung mga units na maka-cancel, no? Para klaro yung unit na ma-retain lang and gagamitin sa final answer. Okay? So 3.5 divided by 36, the quotient is 0.0972 moles. And as you can see, yung number 2 po dito may symbol sa taas. And remember in math, what does this symbol mean? Ibig sabihin, itong number na ito ay repeating. Okay? So, ibig sabihin, non-terminating ito na decimal. Now, is this the final answer? No, because the unit here is still moles. So, we need to convert this answer to millimoles because what is required from the problem is millimoles. So, we convert it. You can use dimensional analysis for conversion. Me, personally, when I convert, I use it. No? So, you just need to, of course, no, know your conversion factors. So 0.0972 moles times the conversion factor 1 mole is equal to 1,000 millimoles. By the way, para malaman mo kung saan ilalagay yung 1 mole, saan ilalagay no, sa taas ba sa baba yung 1,000 millimoles, dapat alam mo yung ano yung required na unit. And alam mo yung ano yung mga units na dapat ma-cancel. Okay? Like in this case, ang kailangan mo ay millimoles, so dapat siya yung hindi ma-cancel. Ang ma-cancel ay yung moles. Kaya si 1 mole ang nasa baba, si 1,000 millimole ang nasa taas. Okay? Now, okay na tayo sa unit, nakuha na natin yung millimoles. How about for the numbers? Since these two numbers are of the same level, so that means you're going to multiply them both. Okay? And you will get 97.22 millimoles. Sir, bakit po 0.22 na isang 2 lang naman po siya dito? Remember, this is repeating. No? Sa calculator, repeating ito siya. 2, yan siya. Okay? But again, when I announced earlier, no, the rules when solving, I said earlier 2 decimal places, no? Round it off to the hundredths place, 2 decimal places. Okay? And then do not round off in the middle of the solution. Kaya nilagay ko yan siya na symbol. Okay? Para alam ko na ay hindi pala yan yung last digit, no? May mga kasunod pa siya. Okay? So ganun po. Next problem. Make 300 ml of 6 molar NaCl. So this one, since it's asking us to make, so that means the final answer should be in a sentence form, correct? So first, to solve this problem, we need first to, again, go back to the formula for molarity and then plug in the values based on the given. So we have here 6 molars, and then we have here no, the molecular weight for sodium chloride, 58 grams per mole, times, remember po, no, liters of solution ang kailangan. But since the given is 300 ml, so we need to convert that to liters. So you'll now have 0.3 liters. So we're going to multiply the 3. You have 0.3 times 58 times 6. And you'll get 104.4 grams. Is this the final answer? No. Maunang wala siya gi-box. Again, we need to answer this one in a sentence form. So you have here 104.4 grams of NaCl is needed to make 300 ml of 6 molar NaCl. Or you can say 104.4 grams of NaCl is added to a solvent to make 300 ml of 6 molar NaCl. Remember, I only use the word solvent, no? Why? Because wala naka-state sa problem kung anong solvent ang gagamitin. Okay? So, mauna siya. Now, let's proceed to molality. So, what is molality po? Molality is the number of moles of solute in 1,000 grams or 1 kilogram of solvent rather than the final solution. So, this is the formula for molality. And as you can see, almost similar po yung formula ng molality sa molarity. Ano lang po yung nagkaiba? Yung nandito banda na portion. Kasi po sa molarity, it's liter of solution. Dito po, it's kilogram of solvent. And for the units of molality po, the unit can be moles per kilogram or small letter m, but I do not advise you, and as a rule, I will not let you use the small letter m because it's very difficult, especially pag sinulat nyo lang, no, handwritten lang. It's very difficult to distinguish if you are writing a big letter M, which means molar, or a small letter m, which means molal. Okay? So, as early as now, I want you to remember to use either this one, no, for molality, moles per kilogram, or yung abbreviation nito na MOL per kg, or ito siya, molal. Wag lang itong small letter m, okay? Okay, so I'm giving 2 problems for this one kasi almost the same lang siya with molarity. Okay, so let's have this one. So what is the molality of a solution if 127 grams of NaCl is dissolved in 1,000 grams of distilled water? So we use this formula. You're just going to plug in the values. So the weight of the solute based on the given is 127 grams divided by the molecular weight of sodium chloride, which is balik-balik na. So memorize na dapat ninyo so far, no? Sa part ng video na ito. That's 58 grams per mole times, since 1,000 grams is given here, so you need to convert that one to kilograms. So if you're going to convert now, that will be equivalent to 1 kilogram. So that's 127 divided by 58 times 1, and you'll get 2.19. And then the unit would be moles per kilogram or molal. Okay? Another example would be this one. So how many grams of sodium chloride would be in a 100 gram of a 1 molal solution? So again, using this formula, formularity, no? So you're just going to plug in again the values. So 1 molal, no? I wrote moles per kilogram here again for you to see, no, the cancellation of units. Okay? So, pero kung hawd na kayo mo, no, pwede na delete na ninyo na ibutang ang moles per kilogram. Pwede kanina lang jud siya, no, molal. Okay? So 1 molal is equal to the weight of solute divided by the molecular weight of sodium chloride, which is again 58 grams per mole, times, since grams is given, so dapat convert yan siya to kilograms. So 100 grams is equivalent to 0.1 kilograms. Multiply these 3 and you will get the weight of the solute, in this case the weight of sodium chloride, which is 5.8 grams. And then you need to box the final answer. Okay, so that's for molality. Now let's proceed to normality. Now normality actually is also known as equivalent concentration. Why? Because it is defined as the number of equivalent weights per liter of solution. Maunang, aside from using the unit capital N, no, which is read as normal, there are times that you will see the unit of normality as equivalents per liter because of this description of normality. And then also, this is the formula for normality, no? The weight of the solute divided by the equivalent weight times liter of solution. So almost the same then yung formula niya with molarity. However, instead of having molecular weight here, you have the equivalent weight. Okay? And remember, iba po yung pag-calculate ng molecular weight at saka na equivalent weight. Okay? So what is equivalent weight? So equivalent weight is the mass of an element or compound that will combine with or replace 1 mole of hydrogen. So this one is dependent on the total charge of the positive ion or the valence of the element. That is why if you're going to look at the formula of the equivalent weight, part talaga si valence dyan kasi dependent si equivalent weight kay valence. So the formula for equivalent weight is molecular weight divided by the valence. Okay, so the unit of equivalent weight is grams per equivalent. That is G/E small letter Q. Okay, okay. So how do we determine the valence first? Okay, kasi alam naman po natin paano i-calculate ang molecular weight. So in terms of acids and bases, madali lang po siya. Bakit? Kasi personally ako, tinitingnan ko lang yung number ng H ng acids and bases. So for example, if you have sulfuric acid, diba sulfuric acid is H2SO4. So from that one, you have 2 H's. So that means the valence of your sulfuric acid is 2. No? Another example, for example, you have a base, sodium hydroxide. So ilan ang H dyan? Isa lang. So that means the valence of sodium hydroxide is 1. Ang medyo mahirap lang po dyan, ang medyo tricky lang po dyan ay ang valence ng salts. But don't worry, no? If ang given sa problem ay salt, no? So most probably ibibigay namin yung valence niyan, no? Hindi lang namin ibibigay ng valence for sure is kapag acid or base kasi masyadong madali lang ma-determine yung valence. Okay? Okay. And this is just a table that shows, no, the valence of some common salts as well as their equivalent weights. So sa inyo, kung gusto niyo ito i-memorize. Okay, so let's proceed with the sample problems. So we have here, what is the normality of a solution that contains 150 grams of sodium chloride per liter? So this one is very simple because it's just asking for normality. So you're just going to use the formula presented a while ago for normality. So normality is equal to the weight of solute divided by equivalent weight times liter of solution. So the weight of solute is 150 grams. Then what is the equivalent weight? Again, to calculate the equivalent weight, it's molecular weight divided by the valence. What is the molecular weight for sodium chloride? It is 58, correct? What is the valence of sodium chloride? It's 1. 1 yan siya. Hindi given sa problem. Sa 1 yan siya, class. Okay? Hindi siya given sa problem, pero nandito rin siya, class. Okay? So, 1. So, 58 divided by 1 is still 58. So, 58 grams per equivalent. Yan yung equivalent weight na gagamitin natin. Times liter of solution. So, per liter man. So, that's 1 liter. Okay? So, solve for this one and you will get 2.59 normal. Or you may write your answer as 2.59 equivalents per liter. And then, don't forget to box your final answer, okay? Another example. How do you make 500 ml of a 2 normal NaCl? So for this one, we need to calculate for the weight of the solute. And for this one, the final answer should be in a sentence form because it's asking how. No? So let's first settle the weight of solute. No? So this is the formula for normality, then plug in or substitute the values. So we have here 2 equivalents per liter. Again, instead of using the normal na unit, I use equivalents per liter para again to show you the cancellation of units. Okay, so 2 equivalents per liter is equal to the weight of solute divided by, again, the equivalent weight of sodium chloride, which was established in the first problem for normality, and that is 58 grams per equivalent, times, again, convert this one to liters kasi naka-ml pa, so that's 0.5 liters. So multiply these 3 numbers, so 0.5 times 58 times 2, and you will get the weight of solute, which is 58 grams. And then since it's asking how, so you need to answer this one in the sentence form. So 58 grams of sodium chloride is needed to make 300 grams of a 2 normal NaCl solution. Or you can actually say 58 grams of NaCl is added to a solvent to make 300 grams of a 2 normal NaCl solution. So pwede yun siya. And then don't forget to box the final answer. Okay? Third, you calculate the barium chloride concentration in milliequivalents per liter of a solution prepared by diluting 25 grams of barium chloride to 2 liters. And then given po dito yung atomic weights ng barium and chloride. Okay? So, kailangan po raw milliequivalents per liter yung makuha. And remember, anong unit nakukuha natin sa normalities? Just equivalents per liter. So, meron pong changes sa gagawin natin sa solution natin dito. So, first, how I solve this one, is first, unahin ko, of course, an equivalent weight. And then remember, di ba doon sa equivalent weight, ang unit niya is grams per equivalent. So, ang ginagawa ko po, yung grams per equivalent na yan, i-convert ko na siya agad-agad to grams per milliequivalent. So, ano yung mini-mean ko? So, ganito yung makikita nyo sa solution ko. Okay. So, this is equivalence weight. Remember, this is the formula to get the equivalence weight. So, molecular weight first, ang kailangan nyo ma-solve. So, molecular weight is 137.33 plus 35.45 times 2. Bakit ganon? Kasi po, di ba, barium chloride, the chemical formula for that one is BaCl2. So that means 1 atom only of barium, kaya po 137.33 lang. 137.33 lang. And then for chlorine, dalawa kasi siya, kasi Cl2. So yung 35.45, you need to multiply that one to 2. Then you add that one to 137.33 to get the molecular weight, divided by the valence. So the valence of barium chloride, if you're going to refer to the table a while ago, that is 2. So the answer will be 104.115 grams per equivalent. Again, don't round off while in the middle of the solution. So the unit now is grams per equivalent. And as I've said a while ago, I convert it immediately to milliequivalents. Okay, so dimensional analysis, So I use the conversion factor 1 equivalent divided, or rather equal to 1,000 milliequivalents. And then you will see that the equivalent unit is cancelled. Ang matitira na lang po ay gram per milliequivalent. And then since the two numbers are of different levels, so that means you're going to divide them. So the quotient now will be 0.104115 grams per milliequivalent. So since milli-equivalent na ang ating equivalent weight, so rest assured yung final answer natin sa normality later on, naka-milli-equivalents per liter na siya. Okay? So now we have the equivalent weight. You're just going to use now the formula for normality. So given that the weight of solute is 25 grams, so you're going to place 25 grams here divided by equivalent weight 0.104115 grams per milliequivalent times 2 liters. Okay, 2 liters, so yun yung given, 2 liters. And the answer now will be 120.06 milliequivalents per liter. And again, don't forget to box the final answer. Okay? And now let's proceed to the last problem. So this one is asking for how many milliequivalents are in 1 liter of a 4.5 normal HCl solution. So as you can see here, it's not anymore asking for milliequivalents per liter, just like the last problem. It's only asking for milliequivalents. So this is how I answered this problem. So first, I use again the formula for normality to get the weight of the solute, because as you can see in the problem, wala pong binigay na weight for the solute. So just substitute what is given. So 4.5 normal, ilalagay ko dyan. And then, equivalent weight ng HCl. Ano malalaman ang equivalent weight ng HCl? Cl, di ba, is 35.45 grams. Hydrogen is 1 gram. So you add the 2 and you get 36.45 grams. And then what is the valence for that one? For HCl, it's only 1. Okay, isa lang man ang H. So 36.45 divided by 1 and you still get 36.45 grams. But this time, kuha na kasi natin is equivalent weight. So it's already grams per equivalent times 1 liter. So you're going to multiply this 3 here, you'll get the weight of solute. The weight of solute is 164.025 grams. Now I will introduce to you another formula. Okay? To get the equivalence, the formula is gram of sample divided by the equivalent weight. Okay? So, hindi tayo pwede diretso kay milliequivalent. So, sa equivalent muna. So, the gram of sample is 164.025 divided by the equivalent weight of HCl, which is, of course, 36.45 grams per equivalents. Then makakancel yung unit na grams, matira na lang si equivalent. So you'll get 4.5 equivalents. Now, question is asking for milliequivalent. So you need to convert 4.5 equivalents to milliequivalents. So using dimensional analysis, so we have here 4.5 equivalents times 1 equivalent is equal to 1,000 milliequivalents. And then, bakit ganito yung positioning ng conversion factor? It's because we want to get milliequivalents and we want to cancel equivalent. So, ma-cancel equivalent, matira ang milliequivalent. That's why milliequivalent yung nasa final answer. Since both numbers are of the same level, so they will be multiplied. And you'll get 4,500. So 4,500 milliequivalents is the final answer and you're going to box it. Okay, so that's all for normality, and actually that is all for expressing concentrations. So before I end this video lecture, I just would like to remind you to continuously practice, since this is the bulk of the prelims coverage for CC1. Continuously practice problems for your laboratory mathematics. This is just the first part. You still have the second and the third part. The second part will be about conversions. The lecture is to be given by Ma'am JC. And then third part for dilutions, it is to be given by Bea. Okay? And then also, don't forget to, again, open the practice set file for expressing concentrations, the topic. Okay, so that you will be mas makapractice kayo, and yun din yung problems na isa-solve natin at ira-rationalize natin during your synchronous class. Okay, so that is all. Thank you for listening.